Section 2.4, Complex Numbers.
First, I'll give you the solutions to the homework problems. If you need to see a problem longer, just hit the pause button on the video.
If you need to see any of the solutions longer, just hit the pause button. Okay, now for our complex numbers. Okay, remember that complex numbers are made up of a real number and an imaginary number. And remember, our imaginary number is the square root of -1. And if we square our imaginary number, we get -1. Okay, now for two complex numbers to be equal to each other, so these two are equal to each other, A has to equal C and B has to equal D for those two complex numbers to be equal. And we can take complex numbers and we can add them together. So if I have A plus BI plus C plus DI, you add the A and C and then add the B and D. And the same thing with subtraction. You can subtract the A and C and then subtract the B and D. We can distribute through our complex numbers. So if we have the negative of A plus BI, you distribute that negative side. Okay, now just to show you some examples of when we're adding and subtracting. I'm adding these two complex numbers together. You just add the two real numbers, add the two imaginary numbers, and we have our solution. An imaginary number plus a complex number, same thing. You have your real number and then combine your complex numbers. Set of three numbers, adding and subtracting, just combine your like terms. Just don't forget, you do have to distribute negative signs. Okay, we can also multiply with complex numbers. So if I have A plus BI times C plus DI, you just go through your FOIL. So first, AC outside, ABI inside, BCI, and last, BD with the I squared. Just remember that I squared equals -1, and then we can combine our like terms. So the AC and the negative BD get combined, and then we can combine our two imaginary numbers, and we'll have our solution. Just so you can see an example. If we have I times -3i, that gives us -3i squared. I squared becomes -1, and we're left with 3. Here we can go through the FOIL. 2 times 4 is 8. 6i, -4i, and -3i squared, which we turn into -1. So 8 plus 3 gives us our 11, and 6 minus 4i gives us our 2i. Another FOILing problem. So first, outside, inside, last, and our outside, inside cancels. And if you notice, this was the 3. Now we can also multiply two complex numbers together. So if I have A plus BI times C plus DI, we can use FOIL on those. So first is our AC, outside ABI, inside BCI, And last, our BD times I squared. Just remember then our I squared turns into -1. So that way we can take our AC and negative BD and combine those, and then we can combine our two imaginary numbers. To see some examples, if I have I times -3i, that would be -3i squared. I squared is -1, so my solution is 3. Here we have to FOIL. First is 8, outside 6i, inside -4i, last -3i squared. I squared turns into -1, so I can take my 8 plus 3 and combine my outside inside, and we have 11 plus 2i. Here, first is 9, outside -6i, positive 6i, and -4i squared. Our outside inside, they cancel each other out.
Sorry, the video got cut short, but notice how the complex number multiplied by its conjugate resulted in a real number answer.
Now you saw in the last set of example problems where if I multiply a complex number by its conjugate, it actually turns into a real number. So that will let us divide two complex numbers. We can just take the denominator and multiply by its conjugate. Then our denominator will turn into a real number, and we can combine the like terms on our complex number. So for this problem, if we have 1 over 1 plus I can multiply by the conjugate of the denominator on both sides. And then that lets our denominator go down to a real number. And we're left with 1/2 minus 1/2 I. Another example, here's another complex number divided by a complex number. Multiply by the conjugate of the denominator. And go through our simplifying and our FOILing. And we end up with 1/10 plus 4/5 I. Okay, the last thing we have is being able to plot a complex number. Instead of an X and Y axis, we're going to have a real axis and an imaginary axis. So if I want to plot the point 2 plus 3i, I go over 2, up 3, and there's our 2 plus 3i. This one is -1 plus 2i. And then if I want to plot 4, that just goes over on the real number to 4.